All right, today we're going to crack a code, a fundamental code that seriously describes how a ton of our world works. And no, this isn't just some dry math concept. It's a rule that's in charge of everything from, well, vending machines all the way to how planets orbit the sun. Yep, we're talking about the mathematical function.
So, to get us started, I've got a question for you. What on earth does a vending machine have to do with math? I know, it sounds a little weird, right? But believe me, this simple machine, it holds the key, the entire secret to understanding what a function really is.
Just think about it for a second. The whole process is super simple and, more importantly, reliable. You give it an input, you press button B4. The machine does its thing, it runs a process. Basically, it follows a rule that's programmed into it. And what happens? It gives you exactly one output. Let's say a bag of chips. The most important part here is how reliable it is. Every single time you press B4, you're gonna get chips. You'd be pretty confused if a soda popped out, right? That predictability, that's the key.
Okay, so that super simple, super reliable vending machine rule. One specific button gets you one specific snack. That is the exact same logic that defines a mathematical function. So let's take a look at the official definition. And here it is. Officially, a function is a rule where every single possible input leads to exactly one output. That's the phrase to remember. Just like our vending machine button B4 can't give you both chips and a soda at the same time, an input X can only, and I mean only, lead to a single output Y. That's the whole shebang. That's the rule. This table here really makes it crystal clear. So look on the left under predictable. That's a working function. Every input behaves itself perfectly. You put in a 1, you get a 3. You put in a 2, you get a 4. Nice and simple. But now, look at the right. This thing is broken. See how the single input, the number 9, is trying to spit out two different outputs at the same time? It's trying to give you a 3 times and a -3. That is our broken vending machine right there. It completely breaks that exactly one rule, so it's not a function. Simple as that.
Okay, so how can we spot these broken ones really fast, especially when we're just looking at a graph? Well, it turns out there's this brilliantly simple visual check we can use. It's called the vertical line test, and it's awesome. All you do is take any graph and just imagine you're drawing a perfectly vertical line, or maybe sliding a pencil, across it from left to right. Now, if your line at any point touches the graph in more than one place at the same time, boom, you found a rule breaker. It is not a function. It's honestly that easy. And check this out. This is a perfect example of a pass. See this U-shaped curve? It's called a parabola. No matter where you draw a vertical line through it, go ahead, imagine it. It only ever crosses the graph in one single spot. That tells us that for every X input, there's only one Y output. This thing passes the test with flying colors. It is definitely a function. Okay, now compare that to this circle. See what happens here? As soon as you draw a vertical line, wham, it hits the graph in two places at once, right at the top and at the bottom. That is a huge visual red flag. It's screaming at you that one X input is trying to have two different Y outputs. It fails the test, big time. This is not a function. All right, so now that we can actually spot a function, we kind of need to learn how to talk its language. Mathematicians, of course, have a special shorthand for all this, and it's called function notation. You're going to see this thing everywhere, f of x. You read it out loud as f of x. And really, it's just a fancy way of saying the output you get from the function f when you put in the value x. That's it. So y and f of x are basically interchangeable. They both just mean the output. But please, please remember this one thing. This is not f multiplied by x. It's not multiplication. It's just a label, a name for the output. Let's actually see this in action. It'll make more sense. So say we have a function named g, and its rule is 2x minus 1. This table shows us exactly what's going on. If we grab an input, let's say the number 2 from that first column, and we plug it into our rule, that's the work column, we get 2 times 2 minus 1, and that gives us our final result, 3. So using our new fancy language, we'd write that as g of 2 equals 3. See? It's just a perfect little system for mapping an input to its one and only one output. And, what's really amazing is that this one simple rule, one input, one output, can create this whole universe of different predictable shapes and patterns when you graph them. You can think of them like different blueprints for how things relate to each other. First up, we've got the simplest blueprint there is, the constant function. Its rule is just f of x equals k, where k is just some number.
It doesn't matter what you put in for x, the output is always that same number. And what does that look like on a graph? A perfectly flat horizontal line. Next is the linear function. This is the blueprint for steady, consistent change. Like walking at a constant speed. Its rule is f of x equals mx plus b, and it will always give you a perfectly straight diagonal line on a graph. Super reliable, super predictable. And then there's the quadratic function. Just by adding that little x squared into the mix, we get a completely different blueprint. That smooth, U-shaped curve we call a parabola. And this shape is everywhere in the real world. It's the path a ball takes when you throw it, it's the shape of a satellite dish, it's all over the place. So all these different blueprints, they're kind of like part of a big family tree of functions. Getting to know these basic family members and their shapes is super useful, because they really are the foundation for a whole lot of math. Here are some of the most important members of that function family. We've already met the straight line of the linear function and that U-shape of the quadratic, but you've also got the S-curve of the cubic function and the sharp V-shape of the absolute value. Each one has its own simple rule that creates a really distinct, recognizable graph. Now, those other columns, domain and range, they just tell you about all the possible inputs and outputs. For now, the big takeaway is just getting to know these core shapes. Okay, so let's wrap this all up. What are the absolute key things to remember? Number 1, the rule. One input, exactly one output. That's it. Number 2, the test. That super easy vertical line test. If it hits more than once, it's not a function. Number 3, the language. F of x is just a fancy name for the output. And finally, number 4, the blueprints. Simple rules create these predictable, recognizable shapes like lines and curves that actually model our world.
And that's pretty much the core of it. So I'll leave you with a final thought to chew on. Now that you get the fundamental rule of a function, this whole idea of a predictable input leading to one single reliable output, where else do you see it? Start looking around. What other predictable relationships can you now spot in the world around you? Thanks for tuning in.